Hello everyone, this is Team Number 1 M Division. The Engineering Exploration course project need statement was to design a bot which plays drums. In this presentation, I'll be showing you the course work, whatever we have done, right from problem definition, then clustering them into subsystems, designing, selecting the designs, and virtual implementation using 3D models, and at last, the simulations. The problem definition. The problem definition was formed after taking into consideration the objectives of designing. According to the need statement and the objectives, whatever we have framed, we have defined this problem definition. It is designing a musical board which plays a drum. It should be automated. It must play two music genres, that is two music tunes. It must switch between the tunes in minimum possible time. Then it needs to be portable. It needs to be user friendly and not look too messy. It should be designed and built within 3 months at an estimated budget of INR 4,000. User should be able to change the genres and the speed of playing. The bot shall stop beating the drum by the choice of user. That means the user has the choice to stop the drum. Based on the functions in the need statement, we have grouped the functions and the sub-functions under 3 major heads in the function tree. One is playing the drum, indicating the process, and the user control. In playing the drum function, we have 3 sub-functions, that is holding the drumsticks, beating the drum, and the ability to play 2 music genres. In indicating the process, that is the user indication system, the user needs to know which genre is being played and at which tempo it's being played. So the indication process works with that. And the user control system, it is used to play until the user stops it. That's a major function in the need statement. Then user can change the tempo, and also wireless control should be there for the changing the genres and the tempos. This is a functional tree. After that, we have clustered different functions in the functional tree according to their similarities and processes into 3 subsystems. First one being the drum playing system, second one being the indication system, and third being the control system. In the drum playing system, we have 3 main functions. Those are holding the drumsticks, beating the drum, and ability to play 2 music genres. In indication system, we have display the current genre being played and display the tempo. And in the user control system, we have continue to play until the user stops it. User can change the tempo and wireless control to change the genres. We've seen in the previous slide, we have 3 subsystems, and the subsystems are drum playing system, that's the major part of the system where it plays the drum. Then the indication system for the tune being played and the tempo, and the control system for the user to control, either to stop the drums or to change the tempo or to change the tunes being played. Based on the subsystems and drawing the morph chart for the needs and the functions, we have generated 4 concepts, 4 designs. In the first design, we have a microcontroller which plays the drum along with a stepper motor. Then we have the tune indicator. It's just a LED, 2 LEDs being used for tune 1 and tune 2. And then there is a photoelectric sensor to stop playing. Just when the user gives a hand near the photoelectric sensor, the photoelectric sensor detects it and the tune is stopped. In the second design, it's a more compact design, and here we have a microcontroller connected to the DC geared motors, and a Bluetooth receiver module is fixed to the Arduino. Then external device like a phone is used to send Bluetooth signals from an app to control this device. So you can change the tunes, or you can change the tempo which is being played, or you can start or stop the drum playing system with this external device. In the third designs, we have used a potentiometer to vary the tempo of play, and we have used IR sensors to switch on and off the drum system, and we have also used car door lock actuator motors for better efficiency between switching the drumsticks. And in the last design, we have used a remote control to switch on or off, and an external display device that's in a Bluetooth module, and we have used servo motors for controlling the drumsticks. Based on the puck charts giving the scores for different parameters and evaluating, we have selected design 2 being the most suitable one for our problem definition and the need statement. It's because it satisfies most of the constraints whatever we have, also the objectives and the functions. So it is the best fit. Coming to the virtual implementation. In virtual implementation, we have 3D modeled our systems and also simulated it with the circuit diagrams and the algorithm for running it. The 3D model for entire subsystem, you can see the drums, the drumsticks, the U-clamp, DC motors which are encased within the U-clamps. This is the external casing, and the Arduino. This is the basic drum playing system, and a circuit diagram for the entire system. It consists of an Arduino. We have the relay modules. A circuit diagram for the entire system. It consists of an Arduino. We have the relay modules. Relay modules are connected to the DC motor, and they are powered by external supply. This is the algorithm for functioning of the entire system. First, the external device sends whether to start or stop. Accordingly, it goes to step 4 or step 1. Step 1 to take the input if stop in an iterative way, or step 4 for receiving the further input. In step 4, it selects either tune 1 or tune 2 in the tune variable, and the tempo. Tempo is just an increased delay or a mediocre delay or a decreased delay. Delay time is adjusted. So I have named them low tempo, high tempo, and a mid tempo. So the tempo variable also is selected. They are put in a if-else ladder. We test them, and accordingly the tune is being played. At last, in step 6, it returns back to step 1 for taking the input again. This is a bill of materials. We have used 2 U-clamps, a foam sheet, nuts and bolts, then cables, and single-stranded wires. Along with that, we have also used DC motor, Arduino Mega 2560 microcontroller, and relay modules for the completion of subsystem. Then finally they are attached to the drumsticks and drum, and the entire system is built upon. This is the motor sizing and the battery sizing of the entire system. The load on the motor is 60 gram due to the drumsticks. Considering the speed of reflexing back of drumsticks, we have chosen 120 RPM DC geared motors. So the calculation is torque, total torque is product of force and the diameter divided by 2. Then the total torque calculated is 0.03 kg centimeter considering the factor of safety of 1.5 and multiplying that, we get the net torque as 0.05 kg centimeter. According to the table and the requirements, we have chosen 120 rpm DC gate motor. So this was the calculation. And in the battery sizing, we are using an external adapter. But if we had used a battery, then we would require 8 amperes of current. So total current drawn would be 16 amperes for both the motors. And this is done using consideration of the horsepower requirement, that is the total power requirement. As total torque is 0.05 for each motor, we have two motors, so it's 0.1. The functional specifications of the entire system. We have majorly 4 functions. We have many functions, but the major functions are 4. First, take in the user input, play the tune, indicate which tune is being played and which tempo is being played on the external device, and then stop when the user desires via Bluetooth. So the functional specification goes as follows. First, the user inputs the tune to be played and the required tempo. Then the tune is played with the code. Then the indication system indicates the tune being played, and finally when the user desires, it stops playing the tunes. Now we shall move on to the modeling and simulation. This is done using Tinkercad. So the code part is used with the buzzer. So instead of drums, we have used buzzers to give a real feel of playing the drums. And the DC gate motors are used with the relay modules as per our circuit diagram.